So first of all, ESA has to get an overview of all the imminent asteroids which might hit the Earth. So we have to scan the sky. We have to develop the telescopes to find these objects. This is a European effort. We have to work together in Europe to find, to develop these telescopes. Once we have found them, we need to process the data. We have to build a database. And we already started building a NEO coordination center in Rome, where this data is made available to European researchers, but also to the public. And finally, we need to define mitigation measures to counter an impact, a threatening impact. Great. So in ESA, we want to observe the sky in order to find out what kind of asteroids are approaching, which are having maybe an impact risk. And that's why we establish a whole network in Europe where we work together with professional astronomers. We have a telescope in Tenerife, a big 1 meter telescope which is observing the sky. We have smaller telescopes run by amateurs. So we try to bring everything together in Europe to make a common effort to find as much asteroids as possible. 4 years ago, there was in Chelyabinsk in Siberia, there was a 15-meter object entering the atmosphere, exploding over the city, and creating a big shock wave, which created a lot of damage. 1,500 people went to hospital because they were hit by fragments. There were no casualties, but this is the size where it gets serious. And if we go further back in history, in 1908 in Tunguska, also in Siberia, there was a big object of 40 meters exploding over a forest and destroyed the forest the size of Greater London. At ESA, we're trying to find objects which will impact the Earth in the near future. Typically objects of size around 20 meters. We don't have them in our databases. We have to scan the sky to find them early enough, let's say maybe 3 weeks before they impact, to detect them, make measurements to be sure if they impact or not, and to calculate the risk and inform the people about the impending risk. If, for instance, in Chelyabinsk in Siberia, where it happened, the people, if they were warned a day before, they would not stay next to the window where the fragments from the shattering windows hit them. So a lot of casualties can be prevented just by informing the people. So for us, it's very important to scan the whole sky, and we need a new technology which has a huge field of view. And so we're developing the Fly-Eye telescope, which basically uses the light from the asteroid and splits it in 16 different cameras. And it's basically working like the eye of a fly, which has the same concept. You split the whole sky in various segments. With the Fly-Eye telescope, we can survey huge parts of the sky, 2/3 every night. And if you have only 4 Fly-Eye telescopes, we would be able to survey the whole sky every night.